Cool. And what are you going to show us today?
We're going to demonstrate how fiberglass insulation conducts energy and radiates energy as opposed to cellulose insulation, which is a far more effective product.
Okay, cool. So what do we have here?
We have a simple little demo board. Two cavities that are R13, they're 3.5-inch cavities, R13 in each cavity. Two 100-watt light bulbs on the bottom that are going to show the conductive and radiatory qualities of fiberglass. This is a simple fan, and if you'll look, follow my finger up here, this is going to show that fiberglass is not an effective air barrier. As you can see just from a fan, that by simply circulating air is flowing through the fiberglass and through the whole product. So basically your air filters are made of fiberglass as well. We'll take this tennis ball and just drop it down in that side. As you can see, cellulose, it is an effective air barrier. There's no air that's going to transmit through that cavity.
Excellent.
If you put your hand up here, you can also feel air coming in from around the receptacles in this side, as opposed to this side you can't. These are two digital thermometers. In the center of each one of these cavities, this number is reflecting the inside temperature inside the cavity, and the top number is reflecting the outside temperature. As you can see from the simple 100-watt light bulb, by the way, we're outside and it's probably 65, 63 degrees right here where we are.
Right.
You can see already the conductive quality of this side, and if you were to put your hand up here, you can feel this one getting warmer as opposed to this one. So already we're seeing a climb of a degree, and you can watch how fast this is going to move in temps. So this is the inside temperature from a simple 100-watt light bulb. The outside temperature, because also fiberglass radiates. It's a solid core product like a metal rod or a glass plate. The top in your attics in your home, it gets 140 degrees up there in the summer. Fiberglass conducts at 125 degrees. So all summer long is spending your money, your dollars, 24/7, conducting heat through your 1/2-inch or 5/8 inch sheetrock. The second law of thermodynamics is that heat moves to cold. So in the wintertime, it's no better story. It's 70 degrees in your home, 30 degrees in the attic. The fiberglass is doing the same thing.
So now what we're seeing is probably not more than about 2.5 minutes later is the temperature on that right side is up to 74 or 75. And
the left side hasn't moved, has it?
No, it hasn't.
Yeah.
Well, cool.
And then we're gonna, this will go over 100 degrees, given that we're in 60-some degree temperature here. So it will go over 100 degrees and stay there. We're gonna turn this off, and we should be able to observe, this is how I get my balls out of here. Okay, we should be able to observe the temperature start to drop in just a moment. We may see a slight tick up from the residual heat that's in there. As we give this a moment, this will demonstrate the second law of thermodynamics, because it's hot inside this chamber, and that heat is going to where it's cold. It's going to go there. So it's going to conduct through this glass back outside until the glass reaches the ambient air temperature.
And we have to remember our in and out are reversed in this case.
Exactly.
We're on the
Exactly. This is the inside temperature, and this is the outside temperature.
Excellent. And the fan is still running, so we're still getting that movement of the air.
Yep.
Cool. Well, thank you so much.
My pleasure.